So let's start today's session.
Yes, sir.
Have we covered this topology, network topology?
No, sir.
So what is network topology? Anyone can?
So network topology is basically the arrangement we have decided to connect our computers in the network.
Correct. And why it is necessary?
It is necessary to maintain our network and to monitor continuously in an effective way.
To monitor continuously. Anyone else?
Sir, two or more devices connect to a link and two or more links form a topology.
Can you repeat it again?
Various stages involved in communication.
Okay.
Connection between the
Hmm.
server printers and other devices.
Correct.
Actually,
Hmm.
network topology means the packet will goes through the path, the shortest path in the network. That's called network topology.
So where is Rajiv? Is one guy. Rajiv. He's not showing it. So the network topology actually play a critical role in terms of performance, security, scalability, right, on a network. Yeah, so the first one is to point-to-point topology. What does it mean?
It is a mesh topology.
Yes.
It is a mesh topology. Every device has decided to connect a point-to-point link. Like one system to another system, one system connected to two, 1, 3, 1, 4, like that.
Okay, means in a
One node
line,
is
right?
connected to the every.
Yes. So point-to-point also known as P2P. So it is
Yeah.
yeah, it's a simplest, you can say that as simplest network topology, right, where two devices connected, right, on each other directly. Just like system one to system two.
Yeah, if any one link damage means it cannot affect other also in this.
Yeah. So this is a P2P topology.
So please repeat your question.
Yes. Yeah, what's your question?
So actually, I wasn't able to hear what you said earlier, so I was asking that.
I just said the P2P means one system is connected to directly to the other system. So its connection may be a wire or a wireless. Right? So why it is called a P2P connection? Because it's directly connected to one point to the another point, means the source point to the destination point, so without any intermediate devices, just like hub and switches. So next is bus topology.
A single long cable connected with multiple devices. Right?
Yes, just like this. So you all have studied these in your course, right? In your BTech course.
Yes, sir.
There will be one system, just like this. All the systems are arranged in a single line, or you can say that a single cable.
or also backbone.
Yeah. So may if one system just broke up, or you can say that a break, so it can affect the other system too.
Yes, the network fails and splits into two.
Yeah. So this is a disadvantage of the bus topology. Although it provide a fast connection, so next is ring topology. So all the devices are arranged in a ring.
Ring form, circular configuration.
Single wire forms a path like in a ring, circular form.
Yeah. Just like this. So let's assume that if the one system got damaged, okay, or disconnected, so it doesn't affect to the other system.
No, its effect no.
No, sir, similar as a bus. Sir.
No, how?
No, it's
How?
no, sir. It will affect us, sir. Its circular form means
It
it
will
will
affect.
affect one damage means. If one damage means, if two damage means, it cannot get three access. Four. It ring forms no, sir. One.
It is
One
one
damage go.
directional? Is it one directional?
Yeah, it forms a ring like
Yes, sir, one direction.
one to two, two to three, three to four, four to five. That rings it form. If three damage means, it cannot get four access. Right. Breaks that
It is
communication.
only one direction, and that is the packet collision.
That means you are saying that if this system got damaged, right?
Yeah.
then maybe the system are not able to access the
Yes,
internet.
yes. Yeah.
Okay. So it's travel in the one direction. I think it's travel in the bi-direction in the boat. So it doesn't affect to the other system like this. Kindly check this whether this is a two directional or a one directional. I think it will be two, not one. Just Google it.
So it's bidirectional.
Yeah. So how it goes? It's bi-directional. Although in the notes here written it's one direction, but it is bi-directional. It's one system got affected, it doesn't affect to the other system. Right? So who is saying that it is one direction? I also got confused.
It's me.
Uh,
It's depending on networks, it behave no. One direction also is there in ring topology. Depends upon network.
yeah, you just think that if the system got disconnected, right? So it may, if it is one direction, that may affect the other system. But this is not the ring topology is not in the one direction.
Okay.
If we have to make the one direction, then we can go with the bus topology, not ring. Why we are using ring?
Yeah, but it is easy to install, no? Easy to reconfigure. And the false identification also can easily find out in ring topology than bus topology. It's in bus topology, adding new devices is difficult. No?
Hmm.
I think you are saying opposite because installing in bus topology it's far more easier than adding or removing devices in ring topology.
No. In both are installation easy, but in bus topology, adding new devices is difficult than ring topology.
No. In ring, it is a little bit, you can say, it tougher than bus.
Because in if you want to install a node or a device in ring topology, it will affect the whole network activity. While in bus topology, it will not affect the working of the other network connected devices.
Hmm. Okay, so let's move to the star topology, right? So in the star topology, actually, there is a hub, right?
A
Hub-like
central.
things, centralized things. Let me erase this. So this is just decentralized devices hub, and all the other devices are connected it individually to the hub. right? So if the centralized hub got disconnected or have any issue, then all the system got down. So this is a disadvantage. So anything want to add here?
It's needed less cabling or more cabling.
What?
For star topology,
Hmm?
cabling is more or less. Correct.
I haven't understand. What is your question?
Cabling is need more or less in star topology.
Definitely, it will not that much, but more than you can say that a bus. It depends on the implementation, right? If the devices are near to it, then definitely it will take less cable. So next
Sir,
is
in star topology,
Mhm.
it uses the point-to-point connections, right, sir? Point-to-point connections.
No
No,
point
no,
one. Yes, central hub it will connect
no.
all devices.
It is connected to the centralized hub. You can say that hub, a switch, a router.
Okay.
So tree topology.
Instead of connecting to central hub, they will connect to central secondary hubs like tree like structure.
Yeah, instead of
Central hub it connected to secondary hubs. One tree branches, two branches,
yes,
like branches it will form.
just like this.
Excuse me, sir.
Yeah.
I think your screen is not shared.
Yes, sir. Screen not showing, sir.
Okay. I hope now it's visible.
Yes, sir.
So this is a tree topology. So here the advantage actually it's allow more devices like to attach to a single centralized hub. So it actually decreases the distance, right? Just in this start topology, we have to connect. Each devices are going to connect with a centralized hub. Just like here, one devices we are using a devices which have the far distance, right? So we have to connect with the hub. we have to use a very long cable, right? But in the branch, we can directly connect it to the other system. Okay, and in the tree topology, the DHCP actually work. Dynamic host configuration protocol. It's actually assign automatically IP address to the each system, and they can communicate easily with each other.
So could you please repeat what you just said?
I just said in that it is star topology. Let's assume that one device is present at a far distance, right, to hub. So to connect with the hub, we have to use a long cable, right? So it also affect the cost. But in the star topology, we can directly connect it to the other system, right? To the nearest system. Just like this is a hub.
Yeah, we can connect more than a star topology devices.
Yeah, this is a hub. So if I connected this devices to the hub, we have to use a long cable, right? So instead of connecting with the hub, we can connect with the other device, right?
Yes, sir.
Yeah. So this is the difference between this and in the you can say that in the tree topology, the DSCP actually work. And you know, guys, very well that what is DSCP and why it is used. Although I can explain you DSCP and in a proper way. I hope it's clear.
Yes, sir.
So, talking about the hybrid, so hybrid is nothing but combining a two topology, just like we combine a tree and a star topology together, where we can combine a bus topology and a tree topology together. That's called a hybrid topology. And mass, about the mass, then mass is just like a mass. It mess up everything. See that this is a system, these are the system. So actually, they are connected with each other, just like this. Just like this. So if the one cable you can say that failed, then it never disconnected, right? Because this is service connected to the one another with multiple cables. Any question?
No, sir.
So let's move to the OSI model. So what is OSI model and why it is used for?
OSI stands for Open System Interconnection.
And
Mention standard.
It will use for communication.
Contains 7 layers.
Yeah, one by one.
So it's a framework which theoretically explains how our packets travel throughout the network from source to its destination.
Okay, from one destination to the another destination, right? But from the client to the server and server to the client. So, what the difference between the OSI and TCP/IP model?
So TCP,
OSIP models has 7 layers. TCP/IP has 4 layers.
Okay.
the OSI model is theoretical based and TCP/IP is practical framework.
So why it is theoretical?
So because initially when we studied about network packets, we used TCP/IP model, which was practical framework, due to which explaining the flow of packets was difficult. So the researchers break down the layers into different parts to explain it easily in a theoretical way.
Yeah, correct. So there are two models, right? In our network, there are two models. One is OSI model and one is TCP/IP model. So OSI have the 7 layers and TCP/IP model have the 4 layers. So each model actually describe how a device is communicating over a network, right? And these devices are what these devices have their communications layer, right? Through which they are communicating. Where each layers actually have their own particular role. So OSI model actually was developed by you can say it international standard of or international organization, right? I think international,
International standards for
yeah,
organization.
correct. International
ISO
Organization of
standard.
Standardization. So they introduce as this OSI as a reference model, right, for a network communication. So it contains 7 layers, starting from the 7th from application, presentation, session, transport, network, data link,
Data, physical.
and physical.
Physical.
Yeah. So can you explain me one by one that what is the role of this and
Now, if application layer is a human-computer interaction layer.
correct?
Any application can be accessed from network.
And in
Like
the
WhatsApp.
in the application layer, which protocol is actually responsible? There are some protocols.
HTTP,
Yes, yes.
HTTP, HTTP,
SMPD.
SMTP.
Okay. So actually, the 7th layer actually provide the service directly to the end user application, right? Just like this, Google Meet, it is working on the HTTPS, right? This is an application, you can say that protocol, where I am interacting here, right? And next is our presentation layer. What the role of the presentation layer and what actually it does?
Data can be encoded, encrypted, and compression of size. It happen in a presentation layer.
Okay, so whatever we are typing here in the applications, right? How it's travel? It doesn't travel like this, right? It should be have a format that can travel through a network, right? So in the presentation layer, actually data is formatting into an computable, you can set it a computer readable format, right? So that a computer can understand. Okay. And from the presentation layer, the tracking of packet is starting. You heard about the PDU? Anyone PDU? Do you know what is PDU?
PDU.
Yeah. Just search it. What is PDU?
So it stands for Protocol Data Unit.
Yeah. So the PDU of the first, you can say that the 7th, 6th, and the 5th layer is data.
Yes, clear. Sandra.
Yes.
It all three comes under application layer.
I don't understand what you have said.
All three together comes under application layer, no? Application, presentation, session layer.
Yeah. Having the same PDU, that is data. Is actually carrying the data. Okay, so in the presentation layer, actually the data is formatted into an you can say it a computer readable format. That's what a computer can understand. And at the presentation layer, the encryption also has started. There is a one interview question, right? That in which layer the SSL and TLS work. Do you know what is SSL and TLS?
Security socket layer. SSL.
Security socket layer. Is it right?
Oh, SSL.
And what is TLS?
Transport Layer Security.
TLS transport layer security.
Okay. So what is the purpose of this?
So TLS provides encryption all that formats.
So SSL and TLS is different things or similar,
Okay. So updated version of SSL is TLS, right?
right? So what the purpose of the SSL and TLS? What actually it does?
When you
Browsing
when you
purpose,
visit a website,
confidentiality, authenticity,
when you visit a website, any websites in background it provides confidentiality,
certification.
encryption, all that.
Okay. Great. Next is the session layer.
It is responsible of controlling ports.
Controlling ports.
Ports. And the connection and responsible of controlling ports.
Correct. It is responsible to actually establish a connection and to terminate a connection and also to maintain a session.
The time between the communication opened and closed.
And
is
it
known
is
as
responsible for cookies also to maintain handle cookies.
Yeah, so it actually create and manage a session between the devices, right? You can set it a login session, a remote desktop session, right? VPN session or a video call session. So all of this is responsible in the session layer. Next is the transport layer.
The data will transfer from source port to destination port with using protocols like
it
TCP,
handles
UDP.
end-to-end communication between devices.
Okay. So in the transport layer, what are the protocols are in the use?
TCP UDP.
TCP and UDP.
TCP and UDP.
And what is TCP and what is UDP?
Transmission
Transport
control
Is a
protocol.
connection-oriented
and-
protocol and
and
it is
user
was
data
error control
protocol.
mechanism.
Okay, Vamsi, speak up.
Yes, sir. TCP is a transmission control protocol and it is a connection-oriented protocol, sir. And it transmits the data in the both the direction.
Okay. And what about the UDP?
So UDP is a user datagram protocol. It is a connectionless and unreliable protocol, sir.
So why it is unreliable?
Because when the data is not transferred to the destination, it cannot retransmit the data and takes the less time to travel the data.
Okay, Himansi, tell me about the
Yes, sir.
UDP and why it is.
So UDP is user datagram protocol. It is a type of protocol which doesn't build connection between the client and server. It directly transmits the packets. That's why it's less reliable, because it's not necessary that all the packets from the server will get delivered to the client server. And it is mainly used in video games and video calls or video meetings where speed is required.
Okay, nice. So it doesn't actually receive any acknowledgement, right? It is connectionless. Whereas our TCP actually a connection oriented and a reliable, right? Before connecting with the you can say that a system, right? It actually perform a three-way handshake. That's make a TCP a connection oriented, right?
Yes, sir.
So any question regarding the transport layer? And one more thing, at the transport layer, our breaking of packets has started, and means the segmentation is started, right? So I hope, do you know that how actually the packets are break? At the first layer, actually, at the road, you can say the application appreciation and the session layer, the data is in the forms of a data, right? Although it was encrypted, but in the transport layer, the breaking of packet has started. It's come under this segmented, right? Or you can say that's a segmentation. Then this break down into you can say that a fragmentation.
IP packets.
Yeah.
So,
In the forms of packets, frames, and then the bits and byte. So the bytes and bit. And the network layer, anyone about the network layer?
it's responsible for delivering of individual packets from source IP to destination IP.
Yeah, it's provide a logical address, right?
Yeah.
Yes, sir.
And what is the purpose of the data link?
So it processes the bits we have received from the physical layer, and it's the first layer which perform the error detection.
Transferring of data from IPs, window IPs like destination IP to source IP to destination IPs.
Okay, so do you know which protocol is used for the error detection? Or which protocol is used to detect the error?
Error control, sir.
Yeah. Do you heard about the ICMP protocol?
Yes, sir.
So what the purpose of it?
So it's a protocol which basically reports errors and like help in IP communication.
Correct. So I hope how you can set it a error detection.
Sorry, sir. What you say?
eh, uh, Hello,
Yes, sir.
am I audible?
Yes, sir.
So I
Yes,
hope
sir.
you know that at a second layer how actually error detections happens, right? And which protocol is in the actually perform this. So that is ICMP. So in the physical layer, all the data has been actually sent into 0, 1 format into the bit format.
It's in the raw bits, in the raw bits with 0 1s.
Yeah. So just like that, our TCP and the IP model, right? So it actually combined the first three layers into the application. Then the transport is as present at transport layer. Network is also present as the network layer, and the last two layer, that is data link and the physical layer, is named as network access layer. Okay.
Yes, sir.
So anything you like to ask here? So I give you some of the task, like what you have to read. Actually, what you have. So just note it down, this thing. the just take a screenshot. There are more question at what layer. So at what where we use IP address
At network layer.
and at what layer we use MAC address. Anyone at what
Data
layer?
link layer.
Uh,
Data link layer, sir.
that is layer number 2.
Yes, sir.
So at which layer we use port number?
Transport layer. Port numbers. Session layer.
Okay. So how many the total numbers of logical ports?
65,535.
65,535.
Yes, sir. Out of those, 1,024 are reserved ports and remaining are unreserved ports.
So the total numbers of well-known ports is
10.24.
1 to
1024.
it's from the 0 or from the 1?
0 to
0 to
1,024
1024.
Zero.
Mm-hmm.
and remaining are unreserved ports.
Okay. So if you see the IP version 1, 2, 3, right? We are using the Internet Protocol version 4. Why? What's about the 1, 2, 3, 4? Sorry, 1, 2, 3. Where is it and why we haven't used it? And why we named as a IPv4? Why not IPv1? If you see the structure, right, of the IPv4, so you see that there are 4 octet, right? And 32-bit address. 32-bit address. Just like 192.168.1.3. Plus. Right. So if you see, so there are 4 octet. So that's why it's called as IPv4. And what the range of it? Starting from the 0.0.0 dot 0 to 255 dot 255 255. Right. Under this, there are a lot of static IPs and the dynamic, static and the dynamic, and also the public and the private. So the total number of address will be 2 to the power 32. It's equal to something 4.3 billion something. Means less than 4.3 billion. But near about 4.3 billion. So do you know about the IPv4? Sorry, IPv5. This is all about the IPv4. And IPv1, 2, and 3. This all are for the research purpose. They never implemented. Although IPv3 have implemented, but is not implemented as globally. Still used by the researchers. So anyone know about the IPv5, where it is used? Is also known as a ST. So what is ST? It's a stream protocol used for the voice and video streaming. But it's never become you can say that the internet protocol. It's used for voice and streaming. Now we see the IPv6. So IPv6 actually developed to resolve our IPv4, right? As IPv4 is uh, exhausting, means it's actually comes to end, right? So that's why IPv6 is developed. IP. So its format is 128 bit. Yeah. Hello.
Yes, yes.
Yes, sir.
Yeah, anyone is saying something? So kindly do study in depth about the IPv6, right? And for tomorrow I will continue from the IPv6. Then we move to the public and the private IP, static. What is static IP and dynamic IP? So in the router, what is it? It is a static or dynamic IP we are using on the router, which is provided by the ISP. Anyone? Hello.
Yes, sir.
Yeah, what is static and dynamic IP?
Static is a constant one, whereas dynamic changes on runtime during runtime of it.
Dynamic IPs are provided by ISP, internet service providers.
It means fixed IP address. Dynamic means automatically change. Yes, on the IP address.
So in our personal router, uh, it is using a static or dynamic IP.
Static IP.
Both, sir.
Both?
Both.
How it possible?
Sir, from the public side, it uses dynamic IP, and for the uh, local side, it uses static IP.
No.
In WAN side, it uses either static or dynamic. In LAN side, it uses only private IP.
Himanshi?
In LAN side, it's only uses static IP.
Okay. Himanshi, what's
WAN,
Sir,
it uses
I-
either pipe public or depending on ISP configuration. In WAN side, it uses either static or dynamic, right?
how it is a static? A static is just like you have to buy, right? You have a permanent IP. Static means a permanent. But our router is the
Uses
IP
static.
is never a static. It's a dynamic. We can't use our router IP address as a static. It is dynamic. We can't use it. For the static IP, you have to buy. Right? You have to buy the IP address from your. You can set it from any ISPs like Vodafone or Airtel or Jio. So the IP address is used by our router is dynamic. Just try to restart your router. You see your IP got changed. What about this? Okay, then this much is for today, right? Uh, we meet at the 4, I think at 4 p.m. So everyone be ready for the classes. And don't forget to join the session, right? The forensic orientation session. Okay, then bye bye.
Sir, can you show your face of you before the ending of the class?
Yes. Yes, Hari, what you are saying?
No, sir, actually before ending of the class, can you show your face before the class ends?
I even understand.
No, sir, actually a photo of you comes as the symbol which you show on previously. So I just asked you about that.
This
No, sir. Actually, your face, which
he asked like, do you want, you want to reveal your face? Like he asked me.
okay, you want to see my face?
Yeah.
yes, sir.
I'll go to the LinkedIn and just search Akash K Talk. There you see my LinkedIn profile.
Just share it. I would last.
Or you can come offline and then just see my face. So this is I.
Okay, sir.
Okay, thank you everyone. Bye bye.
Thank you, sir.